Modern technology has made the operation of wheeled vehicles so easy that many people tend to take the vehicle for granted. Actually, all vehicles can be broken down into several systems, each performing a separate task, yet complementing each other to make the vehicle perform smoothly. If all the systems in a vehicle were listed in their order of importance, the brake system would have to be one of the systems near the top of the list. As a wheeled vehicle mechanic, it is important to remember that the quality of any brake service is always measured in terms of safety. To effectively troubleshoot and perform brake system maintenance, it is essential to have an understanding of basic hydraulic principles. The engine will get a wheeled vehicle rolling, but it takes brakes to stop it. In today's Army, hydraulic brake systems are common, and among those, the ones you're likely to see most often are the drum brake systems used on M151s, the quarter-ton 4x4 utility vehicle the Army has so many of. But there's also another type you need to know about. The M880 1.25-ton cargo truck uses drum brakes in the rear, but up front it has a disc brake system. As a wheeled vehicle mechanic, you've got a lot of personal interest in making sure those brakes are working, because the vehicle whose brakes you maintain or repair, you've got to road test. It's up to you to put safe brake system operation at the top of your list anytime you work on hydraulic brakes of any kind. The safe operation of a vehicle and somebody's neck, even your own, could be at stake. For that reason, we'll concentrate on what you need to know about hydraulic brake systems, what they look like and how they operate, to help you maintain, troubleshoot, and repair them efficiently and safely. When you have viewed this program, you should be able to understand the basic principles of hydraulic brake systems. You should be able to identify the components of the drum brake system used in the M151 and understand its principles of operation. You should also be able to identify the components of a disc brake system like that used in the M880 and understand its principles of operation. In Part 1 of this program, we'll discuss basic principles of hydraulic brake systems that apply to both types of brakes, and then discuss the drum brake system used on the M151 vehicle. Part 2 will cover the disc brake system used on the M880 series vehicle. Get a good grip on the basic principles and you'll be in good shape to maintain brakes or troubleshoot and repair any hydraulic brake system you're working on. First, let's look at basic principles of hydraulic systems because these control everything that happens in hydraulic brake systems. Under normal pressures, liquid cannot be compressed. This heavy weight, for example, cannot press the liquid down beyond its original level. It is, however, putting force on the liquid. This force acts in all directions, putting pressure on the weight itself and on the walls and floor of the container. The pressure is the same at all points. Another thing about liquid is that it occupies the entire volume of the container, filling every space, no matter what its shape. This mock-up has a weight in each cylinder, and we'll call these pistons, like those you'd find in a hydraulic brake system. Let's watch what happens if we push down on one of the pistons, putting extra force on the liquid. The liquid is non-compressible, so its volume remains the same. The effect is to transfer the force to the second cylinder, where it acts on all surfaces, but only the piston is free to move, and so it rises. Now we can see another important principle of hydraulics. The area of each piston is the same, so the right-hand piston rises by as much as the left-hand piston is pushed down. That's because the pressure is the same on the face of both pistons. Let's see what happens if one piston is bigger than the other. The small piston puts a certain amount of force on the liquid. At the larger piston, this same force acts on each area that's the same size as the small piston, so the pressure on the face of the large piston is multiplied by that amount. This means the force applied by one piston can be multiplied many times just by enlarging the area of other pistons in the system. One other thing happens. The smaller piston has to travel farther to raise the larger piston by the same amount as before. The same things happen if, instead of one large piston, there are several whose total area is larger than that of the piston applying the force. Once again, the liquid can't be compressed, and its volume remains the same as force is applied, so the force is transferred to each piston in the system simultaneously. This is like the situation in a hydraulic brake system. The cylinder with the piston that applies the force as the lever is moved is like the master brake cylinder. The connecting pipes are like the brake lines. And the four cylinders with pistons are like the wheel cylinders, except that in each M151 wheel cylinder there are two pistons, not just one. Keeping the principles we've just talked about firmly in mind, let's look at each of those components as they appear in the M151 drum brake system. Let's start by looking at the master brake cylinder. It's hard to see because of the way it's installed, so let's look inside the vehicle. The master brake cylinder is the heart of the hydraulic brake system. The brake pedal moves a piston inside the cylinder by means of this push rod. A reservoir containing brake fluid is filled through this neck. Brake fluid also fills the brake lines through this outlet. They connect the master cylinder to the wheel cylinders at each wheel assembly. For a closer look at a wheel cylinder, let's go right into the brake assembly with the wheel and brake drum removed. In the M151, the wheel cylinder is located near the top of the brake assembly. Pistons inside the wheel cylinder bear against the studs of two brake shoes. These brake shoes are retained by springs, so they are fully floating and self-centering. The base of the shoes engage an adjusting screw, often called a star wheel, and are coupled to it by a return spring that also helps pull the shoes away from contact with the drum. Upper ends of the shoes fit against a hold-down anchor pin at the top of the brake assembly. The brake shoes are surfaced with linings that will wear down as the brakes are used. The brake drum mounts over the brake shoes, which apply pressure to the inner surface to stop wheel rotation. Now, we'll concentrate on the principles of operation of a service brake system using drum brakes like that in the M151. In this system, the brake pedal is a lever that multiplies the amount of force applied by the operator by mechanical means. But that force is multiplied further by the hydraulic system. So first, let's look at the active hydraulic components, the master cylinder and wheel cylinders, to see how that happens. Then, let's see how all parts operate as a system to make the drum brakes work. The master cylinder has two basic sections. One is a storage area called a reservoir for the fluid. The other section is a cylinder which contains a spool-shaped piston. Small holes are drilled through one rim of this piston. The cylinder also contains two sealing cups, a return spring, and an outlet check valve called a residual pressure valve with its own spring. A push rod transfers brake pedal action to the piston. The reservoir contains a supply of brake fluid. It's important to leave some space above the brake fluid to allow for expansion. Brake fluid must not be allowed to drain out of the reservoir completely, because this will let air into the brake lines, and we'll see what effect that has later. Your manual will tell you what the proper level is. Keep it there at all times, and you won't get yourself or the users of the vehicle in trouble. One thing more about brake fluid. It absorbs water, which could cause serious problems throughout the brake system, so keep the reservoir tightly covered at all times. The two ports in the base of the reservoir provide pathways for brake fluid movement. The filler port is larger and supplies brake fluid to the system. The compensating port is smaller and allows passage of expanding or contracting fluid. Fluid movement is controlled by the action of the piston and two cups, which both point forward. As the pushrod transmits pedal motion, the spring applies force against the residual pressure valve, while at the same time the piston cup closes the compensating port. This primary cup faces forward, and as piston motion continues, it seals in the pressure that now starts building up in the outlet end of the cylinder. This fluid pressure unseats the residual pressure valve, opening the way for the brake fluid to pressurize the brake lines and wheel cylinders. We'll look at what happens there in a moment. For now, let's follow the action in the cylinder when the brake pedal is released. The spring drives the piston and sealing cup backward, and so pressure forward of it and in the brake line drops. This brake line pressure bears against the residual pressure valve, tending to hold it open. But eventually, as brake line pressure decreases, the spring overcomes its force and reseats the residual pressure valve. This traps a small amount of pressure in the brake lines and wheel cylinders, and we'll see the effects of that later. As piston motion continues, the compensating port is reopened. Brake fluid flows back into the reservoir through this path. Also, the return spring pushes the piston back faster than fluid can return. This drops the pressure ahead of the cup, so it is now free to flex and unseal the holes in the rim of the piston. Fluid can now return to the outlet end by this path, ensuring that this space will be completely filled for the next braking action. The spring drives the piston back against its stop to complete the braking cycle. Because the secondary cup at this end of the cylinder also faces forward, no brake fluid can leak out of the system. Now, let's get into the other active hydraulic component, the wheel cylinder, and see how that operates. This device is connected to the steel brake lines by a flexible tube that allows for turning and up and down movement of the wheel.